Everyone, this is your math buddy and your math teacher Swapnil again. So today we will be covering unit 10.4, McGrawhill for grade 12 general. Let's get to it. As you can see, correlation and linear regression is the name of the topic. When I say linear regression, I'm trying to find the line of best fit. You will have all the scatter plots, as you can see here. All these 6 graphs are scatter plots. You need to draw the line of best fit. So for example, in the first case, it might look like this. In the second case, like this. Third one is like 2 spreaded. Fourth one is somewhat like this. Fifth would be like this. Sixth would be like this. Sorry. So as you can see, the first one, you always check from left to right hand side. If the line goes down, then it's a negative slope. Negative, and this is strong negative linear correlation. Now, what do you mean by correlation? Correlation is basically the relationship between x and y. So when one increases, what happens to y? It decreases or increases. Same, when it decreases, what happens to y? So it's basically the relationship between x and y. Now, the second one here is going up. When a line goes up, left, right, it's positive slope. So I will say it's strong positive linear correlation. This one has no correlation because the points are spread too much. The fourth one is non-linear. As you can see, it's more like a curve, not a line. So that's why it's non-linear correlation. These two are the special ones. The fifth one here, it is going down, so it will have negative slope, but it will have a weak negative linear correlation. And same, this will have a weak positive linear correlation. Now, how do we know which one is weak, which one is strong? For that, you need to look at the value R. What is R? So R is the coefficient of correlation. R is the coefficient of correlation. It varies from -1 to 1, the value. If it is -1, that means you are talking about strongly negative correlation between x and y values. If it is 1 positive, that means a strongly positive correlation. So more you move towards 0, the more weaker it becomes, as you can see here. So closer to 0 means weak, negative or positive. Closer to 1 and -1, strong, negative or positive. Now moving on to an example to see how it works. There you go. I've written a couple of steps already so that I don't spend a lot of time writing those again. This is the question. This is kind of x and this is kind of y. This is kind of x and this is kind of y. They want me to plot all these points of the graph. So one way is I plot all these points and then I find the line, estimate it. But that is like not accurate. So that's why we have to go through the calculator. In these kind of questions, we have to find 3 things. One, you will find R, which is coefficient of correlation. Second, you will find A. And third, you will find B. So to find all these, I'll use my calculator. That's the good news. Let me just open it. So first of all, I'll clear the memory so that there is no residue from last calculations. So you go for shift. You see CLR 9, 3 equals, and then you press AC. So it's all clean now. Now, step 1, as you can see, to find R, I will press mode. Then I will press 3. 1 is for univariate, one variable x. 2 is for bivariate. I'm dealing with 2 variables here, x and y. So I will choose 2. Now I have to put in all the values. Will get tiresome, but at the end it will be fruitful. So 57, that's 9, 20, 12, 39, 9, 18, 30. So once you put all these values, like it can be tiring sometimes, but trust me, once you're done, your life will be extremely simple in case of linear regression at least. Now let's put in the y values, which is protein, 40, 30, 15, 25, 15, 28, 13, 24, 25, 25, 24. So as you can see, both the values are equal, 11, 11. Now after putting in all the values, you press AC. Now I will press shift. You can see stats 1, regression 5, R3 and then equals. So I'm getting math error because probably I closed my calculator and it bounced back. So let me put in all the values again. All right. So as I've plugged in all the values, now I'll press Shift 1. You see stats, 5 regression, and then I'll press 3 because I want the value of R equals. When I do that, I'll get the value of R, which is 0.8319. Let's round it off to 0.832. So 0.832. Now once I get that, I can get the values of A and B also. Again, I'll do AC, Shift, stats, 1, 5, 1 equals 13.6875. So I'll write it down in some time. Again, to find the value of B, you can go like Shift 1, 5, B equals 0.341. So the B value is 0.341. This is 13.69, I think. 5, 1 equals. Yeah. So once I have these two values, I'll just put in the equation. The value of A is 13.69. The value of B is 0.341. And that will be the equation of the best fit line. So this is one of my answers, and this is one of my answers. Now, if I really want to plot it, I should have graphing calculator, but just to estimate it, as you can see, when x is 0, the value of y will be 13.69. And when y will be 0, the value of x will be negative 13.69, 0.341. That will be, let's do it on calculator. Mode 1, because I want now normal calculations. Negative 13.69 divided by 0.341. That's around negative 40.14. So now once I have these values of x and y, I can just plot the points. X is 0 and y is 13.69. So for example, let's say here, when y is 0, x is negative 40, which is far away. So this value is just an estimated estimation, like not an exact line. Now, as you can see, the value of R tells me that it should, as it's closer to 1, it should have comparatively stronger linear correlationship. And as you can see, the line is also not closer to the horizontal line. So that's how, using the value of R, you can define the relationship, the correlation, and you can find A and B to plot the line. If you have graphing calculator, life will be simpler, but most of the students don't have it. That's why we have done it on scientific. Thank you so much. Keep watching and see you in the next video.